just to introduce myself and SFA Oxford. So I'm Tom Chandler, Principal Lithium Analyst at SFA Oxford. And SFA Oxford is a mining and metals consultancy, primarily focused on PGM, platinum group metals, and battery metals. And we've been working in the lithium industry or lithium space for about 15 years now. And with clients throughout the value chain, not just on things like market intelligence, but also looking at due diligence for projects, various things like that. So yes, DLE, which, in case anyone isn't aware, stands for direct lithium extraction, which is essentially various different processes, but the fast and isolated extraction of lithium from brine, using various different chemical processes and chemical steps. So there are three main methods and two earlier stage methods that I won't really cover. Three main ones are absorption, ion exchange, and solvent extraction. Solvent extraction, okay, sorry, thank you. Yes, the solvent extraction is not commercially available yet and has some environmental issues that may mean it never really takes off. Ion exchange is quite near commercial availability, and adsorption is in use commercially already, and it is also the most commonly selected method of DLE by junior mining projects. So you can see that it's a cover all term for various different combination of chemical processes, but essentially it's extracting lithium from brines without anything else. So as I stated, DLE isn't actually new. It's been used in Argentina, at least in hybrid form, since 1998, and is now used at various different operations in China since 2017. All of these current operations do still use some evaporation ponds, but essentially they are predominantly DLE. There are no pure DLE lithium operations currently. So you can see historically that the majority of lithium came from hard rock mining, and then we had continental brine operations in South America, in Chile and Argentina, coming in the late 80s and 90s. And DLE is still accounting for just a very small slither of production in the lithium market. So if it's not new, then why is it suddenly becoming such a big trend? Why is there so much talk about it all of a sudden? Well, it's down to a couple of things, one of which is the rapidly increasing demand for lithium in BEVs, of course. As you can see here, out to 2030, that the rapid growth in lithium demands in EVs, and on the right-hand chart, you can see that the vast majority of that demand from EVs is for battery electric vehicles. We do have some growth towards the end of the decade in energy storage, but that really isn't going to become an important market for lithium until the 2030s, we don't think. And so because of this, we have a potential situation where we have quite significant market shortfalls without quite a brisk expansion in supply. So you can see here that the green bar is our current balance. And then as you move across, you've got including probable projects and what we call low risk possible projects, which are the most advanced projects that are not yet under construction and that have the least technical risk. But even with these projects included, we end up with quite significant deficits by 2030, which obviously implies that there's several more projects needed and further investment required to bring supply on stream. So that's one way, that's one reason DLE is being incentivized. Another is ESG, and as has been discussed in the panel just a minute ago, ESG credentials of all metals, all battery metals, coming under greater scrutiny. As you can see from the pictures and the images, open pit mining and continental brine operations, solar evaporation ponds, are not the most ESG friendly for various reasons. Quite high on greenhouse gas emissions for open pit mining. The environmental footprint of some of these operations is also huge, and water consumption, especially at solar evaporation ponds, is quite high. There are also other issues related to these methods of extracting lithium, including the risk of groundwater contamination, ecological risks, and various local community disruption, particularly for indigenous populations in places like South America. So then just to touch upon some of these ESG credentials a bit more. So this is just comparing DLE on the second column to solar evaporation ponds and hard rock open pit mining. And you can see that in most cases, DLE is theoretically the winner. So it's got a shorter time to first production, a shorter construction period. The actual production, once the brine is pumped up to the surface, is much, much quicker than solar evaporation ponds, and also quicker than the hard rock mining to get into final product. Lithium recovery rates theoretically or should be higher. Its DLE is not weather dependent, which solar evaporation ponds, as you might imagine, are. A significant rain event can really affect the lithium output from a solar evaporation pond, and even certain weather events can affect hard rock mining, particularly if there's things like flooding. Operating costs, DLE is comparable. It's competitive with both evaporation ponds and hard rock open pit mining. The environmental footprint is a hell of a lot smaller, as you'll see shortly. Water consumption is much lower, particularly if you re-inject the brine back into under the ground. And energy consumption, again, is less than open pit mining, but it's higher than solar evaporation ponds. And as I said, greenhouse gas emissions are much lower. One area where DLE isn't competitive compared to the existing mining methods is capital costs. And I'll get onto that in a little bit. So just to talk about the extraction rates, as you can see, this is just simplified process diagrams of how we get from the brine in the ground to lithium ready for export. And the whole process of extracting and then converting the extracted lithium chloride or lithium ions into either lithium carbonate or hydroxide is a hell of a lot quicker than the traditional evaporation pond route, which, as you can see, the actual evaporation pond stage can take anywhere between 9 to 18 months to concentrate the brine down enough for it then to be ready to go into the processing plant. So compared to the traditional operations in Argentina and Chile, it is a hell of a lot quicker to get lithium out of the ground. And then just to highlight the size of some of these operations. So again, this is, you can see Manhattan on the left and the solar evaporation ponds in the Salar de Atacama just next to it. And these are the largest operations in Chile, and you can see the scale of them is huge. Even one of the largest hard rock mine, Greenbushes in Australia, has a lot larger footprint than the Vent's current DLE operation, which is in Argentina. So as I said, this is a operating cost curve 2026 forecast with some of the DLE operations that we think will come online in that period. And we can see that whilst DLE isn't necessarily the cheapest, it is certainly cost competitive. You can see the brine operations in the blue and the hard rock operations in orange. One thing DLE doesn't do is steepen the cost curve, but it certainly widens it. And so DLE projects should continue to be incentivized by current prices, and there isn't necessarily a risk for, in most cases, that the lithium price coming down at the moment should slow them down too much. As I said, the key risk or the key hurdle for DLE projects is high capex. Now this varies hugely depending on exactly what deposit you're looking at, but typically DLE projects have much higher capex, greater upfront capital on a per ton of lithium produced basis than non-DLE brine projects, and also compared to hard rock mining projects as well. Whilst continental brine DLE projects are not that much more costly, things for unconventional brines such as oil-filled and geothermal brines are typically much, much more expensive, and then and have much higher upfront costs. Another concern is cost escalation. There have been quite a few DLE projects that have had substantial increases in OPEX and CAPEX estimates. And this, whilst is not purely a DLE related issue, does add uncertainty to DLE projects. The DLE operations in China, the ones that there's been a handful that have started up since 2017, have all experienced ramp-up issues. And these are projects that are not pure DLE, but they're hybrids and they're still experiencing ramp-up issues. Whilst delays are inevitable, this added uncertainty isn't helpful, and the risks are likely higher with unproven DLE technologies or unique and unconventional sources. Just in a recent example, at the bottom, you may have seen that Lake Resources' Catchy DLE project was delayed in June. Its capital cost estimates have more than doubled since the feasibility study in 2020, so over $1 billion now, and operating cost estimates have also risen significantly. So, assuming the CAPEX hurdle can be overcome, DLE could be very, very valuable in unlocking new sources of lithium supply. So whether that be jurisdictions such as Bolivia or new deposits such as geothermal and oil-filled brines. So as you may well know, Bolivia has the largest lithium resource on Earth, and the Salar de Uyuni in particular is estimated to contain a hell of a lot of lithium in subsurface brines. The problem is Bolivia's climate is not particularly suited to solar evaporation ponds, certainly not as much as in Chile and Argentina, and it's been one of the reasons why Bolivia has struggled to develop its own lithium mining industry. So the Bolivian government is now focusing very much on DLE. It's created a number of partnerships recently with Chinese and Russian firms, none of which have any experience in DLE, but there are obviously ways around that. And they are hoping to build 100 kilotons per annum LCE capacity by 2025, purely based on DLE technology. This is quite an ambitious target. I personally don't think it will be achieved in this short time period. And regional governments are also less optimistic, and they are aiming for a similar scale by 2030 rather than 2025. Similarly, DLE could make geothermal and oil-filled brine sources viable. And there are now numerous companies looking at these unconventional brine deposits around the world. As has been mentioned earlier, about ExxonMobil, the recent announcement that they've come out with. They've been looking into lithium for quite a bit of time now, along with various other companies such as PetroChina and Chevron. So just to touch upon this a bit more, the DLE trend of the oil and gas industry looking into lithium. So ExxonMobil entered the lithium industry in May when they acquired property from Galvanic Energy. This is an oil-filled brine project in Arkansas on the Smackover Formation, and based on independent estimates done before the purchase, this particular property contains 4 million tons LCE resource, which is very considerable. And the company themselves, Exxon themselves, wants to produce between 75 and 100 kilotons per annum LCE by 2030 from their deposits. Likewise, PetroChina is looking at lithium extraction from gas-filled waters in China, and produced lithium carbonate from these waters for the first time in January. This is China's first attempt at looking at this kind of deposit, and it's again shows the wider oil and gas industry interest into lithium, and particularly unconventional lithium brine sources. In Chile, you may have seen about the National Lithium Strategy, where DLE forms a key part of their new strategy, with the government wanting new projects in the country to focus on DLE. And they're also encouraging existing producers in Chile, SQM and Albemarle, to use DLE or to look into DLE. Both companies obviously use evaporation ponds currently. SQM themselves are already piloting DLE technologies as part of a $1.5 billion investment into reducing water use without reducing lithium output. And both companies, Albemarle and SQM, plan to introduce or implement DLE by 2030 or before 2030. So then just to look at more detail about oil field brine. So this is mainly related to Exxon, but just how oil companies' core capabilities are very well suited to oil field and geothermal brines. They could use much of the same technologies as they do in their existing industry. And DLE systems can also closely resemble oil and gas processing facilities. As you can see on the map on the left-hand side, Magnolia is roughly where Exxon's property is that they recently acquired, and they're planning to extract lithium from. And that's part of a huge formation called Smackover Formation, which is over 600 miles long. Their part of that formation is only 0.5%, which implies if there's consistent amounts of lithium throughout, you would have a hell of a lot of lithium in that formation. Whilst grades are inevitably going to vary throughout that formation, there may not be lithium all the way through. They have found grades in East Texas, just over the border, that are comparable with those in Arkansas. So the potential is huge, and basically any oil and gas reservoir could contain quite significant quantities of lithium as well. As we've seen, and companies like PetroChina, Chevron, Equinor, and all sorts are really focusing in and investigating these lithium opportunities. And just to quickly point out the chart at the bottom right, the grades are actually comparable to some continental brine projects. So we're not talking terribly low grades here. They are the Standard Lithium's operation in southwest Arkansas is comparable with Eramet's DLE operation in Argentina. So the grades typically are competitive. So what does this mean for the market with all this investment, all these companies looking in to DLE and it opening doors to these new unconventional brines and potentially new countries, new jurisdictions, particularly Bolivia. So these are just quickly highlighting the active DLE projects that we're tracking around the world currently. There's around 40 in both North America and South America, and there's quite a few in Europe as well. You may have seen a number in the UK, but there's geothermal DLE operations or projects in Germany, France, and Italy as well. So looking at Europe, DLE is likely to be pretty crucial to its self-sufficiency. So as the panel just spoke then, the targets that the CRMA has set out for extraction of 10% of EU's consumption should be extracted domestically by 2030. Based on the projects we're tracking at the moment, this is unlikely to be met unless DLE projects succeed. So the obvious example is Vulcan in Germany. That's the largest project at the moment, but there are various other ones, like I said, in the UK and France as well. But we still consider them relatively high risk. So like I said, there is quite a real risk that Europe is going to fail to meet the 2030 target in terms of extraction and probably processing as well, as was discussed in the panel just a minute ago. Obviously, local opposition and permitting issues are causing real headaches for European projects, and we've all seen what's happened at Jeddah in Serbia, and also in Portugal and Spain. And therefore, Europe itself is likely to be reliant on imported lithium, either raw material or lithium products by 2030. But the competition for that is going to be fierce. So you've got a lot of investment from Chinese companies in Africa, and a lot of the African material may not be available to Europe and European companies. And also because of that, to counter that, various American companies are also looking into Africa as well. So there's going to be a significant fight on Europe's hands to get enough lithium to have a self-sufficient supply chain. And then on a global picture, so this is demand versus supply in 2030 on the left-hand side. So this, as you can see, is each of the demand end uses stacked up alongside the supply from existing operations, recycling, a probability assessed supply from projects, of which DLE accounts for about 20% in 2030. And you can see we have a potential shortfall still of the equivalent of the production of 6 million BEVs. That's not to say that 6 million BEVs are at risk necessarily. It's likely that lithium use would be substituted in other end uses or energy storage, but it's just to highlight just how much of the shortfall there may be in BEV terms. And then when we include the earlier stage DLE projects, like some of the ones I've mentioned, ExxonMobil, the ones that are sort of going ahead in Bolivia, that could add almost another 900 kilotons per annum LCE, or kilotons LCE in 2030, which would theoretically be enough to fill that shortfall for global demand. So in summary, is DLE the future of lithium production? Well, I do personally believe that DLE revolution is on its way. There are obviously some hurdles, high capex being one of the main ones. It isn't necessarily going to come on as quickly as companies involved in the space might suggest, but it could unlock supply from Bolivia and unconventional brines, which in terms of brines would be more ESG friendly. And this could bring about a lot of additional supply into the market, particularly with the investment from the oil majors such as ExxonMobil, who have the skills and the money to essentially make it work. So based on that, the number of DLE projects that we see, there could be an additional 1 million tons of extra supply purely from DLE projects by 2030.
Hi, thanks for that. What would you say are the 3 generic risks an investor trying to assess a DLE project should be really trying to get to grips with?
Yeah, so I think the key thing is grade's still very important. So, there's a number of projects in places like Canada that are much lower grade. The technology choice I still think is important. There's a lot of unproven and still quite early stage technologies. While, a lot of companies go for absorption, but there are so many different versions of that technology. And there are so many different companies trying to produce their own versions of this technology. A lot of companies are looking at those that are already used in China, particularly just because it's used at all the DLE brine operations in the country. But yeah, that would be important. And then it's a lot of these projects, like, for example, geothermal brines, you get geothermal energy potentially as well. And you can look in the brines and theoretically you could then decide to extract something else as well if you wanted to. Some are already looking at places where they already have the geothermal energy plants there. So you've already got that structure set up. but others, are essentially from scratch. You can also do the similar things at bromine operations, which Albemarle are looking at in Arkansas as well. So there's quite a few key things to consider, but certainly the technology choice and just the basic fundamentals like grade are important. Thank you very much.